Hello, hello. Would you please turn Marc's mic on because we're going to do something a little different?
Uh-oh. We are?
We are.
We are, yes, definitely.
So I've got all this cool stuff written down about what Marc does and what he's done and where he got educated and all that kind of stuff. All right, here's what I want to say. Right now is such a pivotal and important time in the research of ufology, okay, the research of UFOs. Now more than ever, we have to be very, very careful how we examine the evidence. We have to be better scientists than we ever have been. And the reason is that we're educating the general public. Not you guys, you're the choir. Okay, you're the choir, all right? So to educate the general public, we've got to make sure if we say it's a UFO, we know it's a UFO, and we're looking at the data very, very carefully and critically and not getting emotional or new age and cosmic on this stuff. We love talking about all kinds of cosmic things in here. But now more than ever, we need good scientists to be involved in this. And this is the kind of guy we need involved in this phenomenon.
That was very nice. That was very,
so
very
nice.
nice.
It is a godsend that we have Marc D'Antonio involved in researching this phenomenon.
Thank you.
Come on up.
That's so cool. So
yeah.
Is that it? No,
That's it.
Okay. Wait, there's some things on here. Don't you want to talk about all these other things I've done? No.
Let's talk about how great Marc is.
I'm kidding.
Film, TV and film industry, yeah, he's done a lot of that.
Yeah.
A lot of TV shows. He's published stuff. He runs a couple of remote observatories, which is very cool.
Those are cool, I got to admit.
Yeah, and anybody can log in and see what they're seeing.
It's all free.
It's on here somewhere. It tells what it is.
Yeah, Sky Tour live stream. I got cards.
Yeah. So yeah, that's very cool because I've always wanted to own a really good telescope, but I've just never.
Well, you don't have to buy it now. You can just log in and watch.
Exactly.
Actually, you don't have to
saying.
log in.
Yeah.
You just got to join our YouTube channel and bam.
Right.
Watch the universe live in real time.
So yeah. So there you go. Tell us what you know, buddy.
All right. Well, thank you. Goodbye. Thank you, Forrest. I've known Forrest for a while, as you can imagine. He's really brilliant and has a lot of... He belongs here, too, He should be speaking because he's a really smart guy. And no, I'm not blowing smoke. Maybe a little. Oh, is he still here? Oh, I'm kidding, of course, and he knows that. First, before I get started, I just want to thank Nancy and the folks at Ozark. So let's give them a round of applause, okay? This is a phenomenal conference. And I'm honored to be invited back. How many of you were here when I toilet papered the audience? I don't see too many hands. I had put the entire history of the Earth on a roll of toilet paper because I was trying to point out how time scales really look when you look at it from a different perspective. You hear dinosaurs died 65 million years ago. Okay. How long ago was that? I don't know. Well, on a 117-foot piece of toilet paper, that starts with the formation of the Earth all the way to the present day in the room. I made that. Lots of stuff on it. I have no life. I ended up putting all this stuff on there, and when you finally get near the end, you find that dinosaurs died 22 inches from the front out of 117 feet. They're recent history, not ancient history. Isn't that something to think about? Right? And then there's an explosion of life all the way to present day. Now, there are people out there that say, no one's going to find us out there. We're just this tiny little planet. All right? Well, how many have we found? You'll find out, I'll tell you. Okay? And how many might have life? You'll find out, I'll tell you. Okay? And how can we get there? You'll find out, I'll tell you. And how is it that they might have found us, which I think they have? I'll tell you. Avi Loeb just came out with a statement the other day, Harvard Astrophysics, and he said that he thinks that they may move interdimensionally. Now that sounds outlandish because you think interdimensional, ooh, ah. Is he going woo-woo? Is that a woo-woo thing? No, it's not. And in fact, I've been talking about it for a number of years now. It's one of the more popular concepts that I talk about is this process, and you're going to hear it today. Now, as we move forward, I'm going to talk about early astronomy and the things that we've done to move out into the universe, to look at our universe. And it starts with the early tablets, okay? It was 17,000 years ago. There were cave paintings that actually had constellations and stars on them, all right? This is really amazing. And then 3,000 years ago, the Mesopotamian tablets. Okay, 1,000 years ago, 1,000 BC, sorry, we had the Babylonian tablets. You know, we had the Romans and the Greeks naming the objects in the sky, Jupiter, Mars, right? Mars, god of war, Jupiter. Okay, so, you know, we were constrained to be without instrumentation for a long time. And then come along the Greeks, and we see that the Greeks created that ugly thing. And it looks ugly now, but it didn't. This was an astrolabe. An astrolabe was a device. This one actually was very complex. It has gears and objects that slide around. Not anymore, but the reconstruction does. It was an elaborate device used to calculate the positions and changes in the night sky. Wow. You can imagine Pythagoras, an ancient philosopher and astronomer, using this object. If you think about it, weird to think about, his DNA might still be on there in some way. We could clone him. I just thought of that. We should get some DNA. Of course, our luck, we'd pull out DNA of a mosquito, and who knows what we'd get. So there's lots of instrumentation. And in 1054 AD, the Chinese, this object was seen in the night sky, and it was a bright star. It didn't look like that, because they couldn't hope to see that. This is what the Hubble Space Telescope sees, all right? But what was there was a bright star that appeared in the daytime sky. You saw the sun, a bright star in the sky. You're an ancient person in 1054 AD. What do you think that is? How do you correlate that to your understanding of what's overhead? We'll never really know, because everybody had their own ideas back then. But honestly, when all you had was your eyes, there's a limited amount of information you can gather, right? Now, telescopes came along in the early 1700s. Among them was a telescope made by William Herschel. William Herschel had this amazing telescope. It was a 43-inch diameter mirror on this telescope. But wait, was it a mirror? No. It was a piece of curved metal that was polished to a shine called speculum metal. Isn't that crazy? And that stuff had to be polished every day, multiple times a day. And to use it, he had to find his way up this ladder, okay, and slide this whole assemblage up and down to meet the opening of the telescope. And how did he view? He viewed by going like this. Looking in the opening. Don't fall in. Okay? So it was really quite an amazing telescope for its time. And then later, we ended up graduating to refractors. This is the famous refractor at Lowell Observatory. It's a 24-inch diameter objective lens, and you can see that the barrel of that telescope is going to be about 35, 40 feet long. When I was getting my degree in astronomy, I ended up using a telescope like this. It was 20 inches in diameter, and the entire floor of the building was an elevator. And when you moved the telescope someplace, you saw the eyepiece way up there, literally maybe 30 feet over your head. And so you had to raise the floor, you know? And around the edge was just one single row of pipe stanchions as a barrier. And you're working in the middle of the night, deep in the winter sometimes. You can't see because you can't turn on lights. So you didn't have a cell phone with a camera light in there to show your way. You didn't know where you were going. You could step off and fall into the basement. They wouldn't find you till morning, if then. So it was kind of an interesting work experience. I did that for 4 years. I worked on the parallax program at the observatory. And then coming along, we started to be a little more safe. We came up with the Palomar telescope, really interesting telescope. And again, this is our journey out into the cosmos. This is kind of where it goes. These parts right here are tubular structures that are called a yoke. And they hold this long barrel, which is the telescope itself. And you see that little opening right there? The guy, actually it was guys only back then, sorry. He would actually climb into that. It was called the observer's cage. And he'd ride around with the telescope as it was taking pictures. And by the way, you couldn't heat the whole building because it had to stay at the same temperature as the outside air. And the reason for that was because you had to make sure that there was no disruptions through that open slit of the dome, because you would get them. Now, the observatory I built in the Arizona desert, I have the whole roof just slides right off and exposes the whole interior. And that way, the temperature stays the same all night long regardless. And if I was in there, if it was cold, I would freeze regardless, okay? I had one on my front lawn in Connecticut, but it was a dome. I had a dome, like that's a dome. I had a big dome on my front lawn. It was the talk of the town. People drive by, what's that? Take pictures. I heard online, missile silo on the front lawn. And so for Halloween, just to break it up, you remember the movie Despicable Me and the Minions? You know, banana, right? Okay, I actually decorated that dome to look like Stuart the Minion. Okay? And there's Stuart standing with one big eye, looking out at the road. Oh my gosh, that was like, it went over very well, I should say. And then they didn't call it a missile silo anymore. They realized what it was. So we've gone, this is the 200-inch. That telescope was instrumental, still is, in getting us all kinds of information about the night sky, bringing the universe to us. Now the Keck telescopes on Mauna Kea, these are like 33-foot diameter mirrors each. And they're twins. And they have what's called AO, adaptive optics. If you look really carefully, you can see that inside here, these mirrors are little hexagons. There's hexagon mirrors all next to each other. And together, they make one logical mirror. And each of those mirrors can articulate by computer that calculates the turbulence created by the air. And so what happens is you remove all the fuzziness the atmosphere causes, and you get much better views of the night sky. Adaptive optics is now even available for you if you had a telescope. It's $15,000 for your small telescopes, but you know what? It's available. Down the line, it'll be cheaper. In fact, it might be built into all the new telescopes you get someday. Okay? So now, this is ground-based, and along the way in our research, we wanted to go out into space. So what did we do? We created ways to look at objects out in space. One of those telescopes we created was called the Spitzer Space Telescope. This one had a 3-foot mirror and was able to see some really incredible things in the night sky. It's the first time we've ever looked at the night sky in the light of infrared. Why is that? We could do it on the mountaintops, and we have. The infrared energy, the bulk of it does not reach the ground. All right? The atmosphere is extremely efficient in filtering that out. We don't see it. So the Spitzer, being in orbit, could actually look at galaxies and other nebulae and so forth and see them in ways that we could never see them before. Every one of these images is false color, only because they're trying to call out specific details. These are research photos, not actual, object photos. Okay? But then after Spitzer, we said, well, you know what? Let's do the Hubble. Let's get Hubble up there. Let's get a telescope that looks like our eyes look and sees what our eyes can see. Okay? And the Hubble, they said, well, we don't want to just do that. Let's also add a little capability to see in the infrared like the Spitzer. All right? Didn't do as well, but this is what it saw. This image here on the left, these are the pillars of creation. Okay? Now, I happen to know this is in Messier 16, which is the Eagle Nebula, it's called. It's a very, very small part of it. And this is the visible light view. Okay? Again, false color, taken in what's called the Hubble palette. Don't even worry about that. It's just made to look better so you can see it. This one over here, though, this was taken in infrared light. Now, wait a second. Where's all the stars here that we see here? This is the same object. How come we're seeing all those stars over here? We're seeing them because many of those stars are hidden in the dust that you don't know is there on the left image. And so they show up on the right image because the infrared telescope can actually see the thermal energy coming from those stars buried in these clouds of dust that you don't even know is there. So that's important. So when we move outward further, we said, why don't we start looking for other worlds? Because we know they must exist. Let's confirm that. So we started launched the Kepler Space Telescope. The Kepler Space Telescope found over 5,000 different amazing planets that are out there, and those numbers are sure to double. Now, it's possible that 20% of all the worlds that that Kepler found are habitable zone worlds where it's sort of like the Earth in a way where it's not too hot, not too cold, and we can have liquid water on the surface. And if you have liquid water on the surface, it means that you then have the ability to possibly have life. Why? We came from the oceans. You ever notice you're salty, right? I'm not talking about how you talk. But you're salty because we have a love affair with sodium and the ocean. And so when we left the ocean, we took a little vestigial ocean with us and we contained it in an organ called skin. And we carry it around with us everywhere we go. You're mostly water, mostly ocean. It's not the same salinity, it's far less, but you still are carrying it around with you. Hi, I'm the ocean. Okay, that's right, I'm the Pacific. Okay, I'm only the Indian Ocean. Okay, so in other words, you have a vestigial ocean within you, and it's a remnant of where we came from. All right, so along the way, we launched something called TESS. I had the opportunity to work with the CEO of the company that Orbital ATK, and I did a project for him. And TESS stands for Transiting Exoplanet Survey Satellite. What's neat about this is Hubble would do a pinpoint thing. Okay, Hubble would look at one star at a time, so it'd see one star. Okay, TESS, on the other hand, was looking at 24 by 96 degrees of space at a time. Okay, and when it would do that, it's looking for planets that are transiting the star, crossing in front of the star as seen from Earth, in every single star in that image all at once. So instead of doing a pinpoint like Kepler, this one did a vast swath at a time. And it found over 2,000 candidates right away. So it's actually really cool. Now, why am I telling you all this? Because we're looking for other worlds like our own, right? So enter the James Webb. James Webb Space Telescope. This is a 21-foot diameter mirror on this one. Notice it's also hexagons. Okay, that's not because it's doing adaptive optics. It doesn't need it out there. It doesn't need to wiggle the mirrors to make the image better. That's because they were folded up and put in a small package, and then it unfolded once it got to space. Hundreds of different things had to go perfectly right for this to get deployed properly, and hundreds of them went right. And I remember when they got the first image back from this amazing space telescope, I was like, amazing first light, look what we've got, And it's got 6 lines because it's got these 6-sided mirrors, okay? And so this was the very first image, and that was fantastic. It's going to lead to many different things. And if we compare it and see where we've come, the Wide Infrared Survey Explorer, WISE, there on the bottom left, okay, that's the field that was taken with the WISE. The next one over is Spitzer with a 3-foot diameter mirror. And the next one over is the James Webb. Look at the difference in quality of the same location taken with the 3 different telescopes. That's incredible, So we're looking out there. We're looking out there for life as well. And when we look at the Hubble telescope image that we saw earlier, compare that to this one taken by the James Webb. This one is absolutely phenomenal. Now, it doesn't look very different from this previous one. And we're talking about the one on the right. Because the one on the right is infrared, and so is this. All right? But this one has more than 2 times as much data and information in it. Why is that important? It's important because we have to look at how we're progressing to find life in the universe. And we're an infant species. I mean, we're only 5,000 years past the ancient Sumerians and pecking on tablets. okay, and the cuneiform tablature. I mean, we're only 5,000 years past that, and we're already looking for planets around other stars. What if there's a civilization out there that maybe, I don't know, say 5,000 years ahead of us? What might they have done, and what might they be doing? And with the universe with time to spare, what might be the case for a civilization that's 1 million years ahead of us? What might their technology look like? So there's so many things. And so we are conscious of the fact that they might be looking for us. And so is a lot of other groups out there in the world, including our U.S. government. So what does the U.S. government think about alien life elsewhere? Is the U.S. government trying to hide it from us? Well, we all know. Okay. Gee, no. I don't think they're trying to hide anything. Come here, you. You know, it's like, okay. However, and I'll be honest with you guys. For decades, I had a very high clearance. I worked for the Navy. I did special projects. I've seen a lot of projects. One particular project I worked on was classified, no longer classified. That's why I can talk about it. And I called it the Birdie, okay? And it was a device that would come out of a submarine, unfold its wings, go to the surface, take off like an airplane, go fly a sortie to do reconnaissance, land on the water, fold up its arms, go back into the missile tube, and go home. Remember Voyage to the Bottom of the Sea? Yep. The flying sub? We made one. Okay, and I did a lot of the engineering models for the Navy. And you can actually see this. If you look it up online on Wikipedia, it's now publicly known as Project Cormorant, like the bird, C-O-R-M-O-R-A-N-T. Project Cormorant. Look it up, you'll see it. And you'll notice right next to it, it'll say, canceled. Canceled. Yeah. I'm sorry, did I say something? It's canceled in terms of who's funding it now, but it's not canceled. They move forward from a different perspective, different approach, and the same project's now under a different agency. So therefore, the previous agency, yep, it's canceled here. Put that on Wikipedia. Well, while they were testing that, and it was being tested in Bayview, Idaho on Lake Pend Oreille, I got photos of this UFO flying over Lake Pend Oreille. Uh-oh, I know what it is. It's the Birdie. I called the program office and I said to them, a photographer in Bayview captured the Birdie doing something in the sky here, and he's calling it a UFO. And on the other end of the phone, I got, that's great. Let them think it's a UFO. No. Okay, because they wanted to use that, right? We know that disinformation happens too. But I ended up saying to them, no, you know what? One photographer, he's going to go back, tell his friends, and they're going to come back with 10 people. And those 10 are going to go back. You're going to end up having 300, 400 people all watching your Birdie doing a classified test. You really want that? Because sooner or later, one of them is going to photograph the Birdie doing something that you don't want them to know about. And I got, crickets on the other end. And the guy said, okay, let me write up a statement. I go, probably the best approach. Next day I got the statement, I put it out there, everybody went home because they knew it was one of ours. There are people that want to know about our stuff, but then most of the people, like you, like me, they want to find real data, real information that shows that this isn't just, one of ours. It's something otherworldly. I'm going to talk about an otherworldly experience I had with the U.S. Navy, actually, in a short time. So the thing is, our government has a habit of clouding the issue, doesn't it? Right? I'm sure all of you are saying yes. And then the one government kind of acts, well, no, not at all, Get him out of here. No. But the truth is, if we think about this, have they helped the conversation at all? Have they fed information? And has the movie industry had anything to do with this? Now, we know about many different movies that are phenomenal. Here's one. Remember this? Name the movie. Almost in unison, right? Klaatu, Niktu Barato. That's right, Klaatu. This is Klaatu. And of course, obviously, the big robot, Gort, would come down. You're like, big guy in a suit going, I can't breathe in this thing. Okay, but still, I do visual effects, so I kind of dig in. But think about this. This movie was a message of a warning to the human race, right? How about this movie? Yeah, the Xenomorphs. What movie? Alien 1, 2, 3, 4, all the way to 20. Yeah, Alien, that's right. And this was a message of danger. Aliens want to eat your brains. And they don't have any eyes. They have big, long heads, and they breathe, and they spit acid. Okay? Ridley Scott could have made more nightmares for too many people, including me. Okay? All right? So that's a message of danger, Then we had this one. What's the name? Prometheus. And these are called engineers. That's right. And the engineers, you see, this was a message of indifference. Okay? Because the engineers made the world, made the human race, but we failed. So they were going to wipe us off the map. We're going to start over. That's the message there. They were indifferent to us. Okay? And then we had, oh, come on. E.T. phone home. Yeah, Elliot. Well, E.T. was a message of benevolence and kindness. Nice aliens are out there. They don't really want to mess with us, but they're not going to hurt us. I mean, that's kind of what the message was there. As opposed to this one. Independence Day. Right? I mean, heck, the president had to fly a jet into the corridor thing to kill him. Okay, at the end. Oh, I just gave it away. I'm sorry. So, and Independence Day was that message, right? And then, of course, Close Encounters of the Third Kind. Okay? Now, Close Encounters of the Third Kind, I had the amazing opportunity of working with Douglas Trumbull for 10 years. Doug, he did all the visual effects for Close Encounters, 2001, Blade Runner, all these things. And he was a UFO hunter like I am. And he and I got along famously. We really enjoyed each other's company. He passed away, unfortunately, from mesothelioma. But we lost a great man. But the thing is, that message there was a message of kind of hope with promise for the human race. And what's interesting is Steven Spielberg even chose to include this guy in the movie, J. Allen Hynek, right? Which is actually pretty interesting. And the reason I bring all this up is because the point is we're going out into space. We're using our telescopes to look for things in the sky, look for potential life elsewhere. We're at over 5,000 planets. Okay, we're moving forward, and now we're starting to look for other clues to show us that there is actual life there. And we'll talk about that too. Now, the question is, why is the Earth so visible to life? Because we're looking for them, so might they not be looking for us? We're doing it, and we're only 5,000 years into our actual civilization where we write our history down. So they certainly have, without a doubt. And I like this rendering, Earth being so visible, we are, in fact, a pale blue dot. Or, as my favorite astronomer used to say, we are a pale blue dot in the universe, our Earth, our home, right? Carl Sagan, amazing guy, right? And the pale blue dot concept stuck with me ever since I was a kid. And I will tell you that the pale blue dot is not as invisible as you might think, all right? Because when our Earth, and those that saw the toilet paper history know this, as the Earth developed, very early in its history, it started making something that made us very visible to the universe. And that's oxygen. Phytoplankton made oxygen, all right? Oxygen is something that carbon-based life requires to exist. That's us. We're carbon-based. And oxygen being required means that an alien species that's carbon-based is going to look for oxygen in a planet's spectrum if it can see the atmosphere. Well, how can we see the atmosphere of a planet light years away? Not so hard. When the planet passes in front of the star, it pollutes the star's spectrum with enough information that we can read that spectrum and see what the planet's atmosphere is made of. James Webb just did it. And guess what it found? Didn't find oxygen, but it found something called dimethyl sulfide. Who heard that? Who heard? Yes, a few people had their hands up. Dimethyl sulfide all right, is two methyl groups, which is CH3, okay? Make it CH4, that's methane, pew, okay? But you add a sulfur in place of one of those atoms, okay? So it's CH3 with a sulfur and a CH3, dimethyl, two methyls, and a sulfur, dimethyl sulfide. It stinks. It smells. It's also known as the smell of the sea. And you know what creates it? Life. Life is the only thing on Earth that creates dimethyl sulfide naturally. Okay, so you know what that means? That means that the James Webb Space Telescope may have just found life. Sorry, I get so excited I can't talk. So that's true. So around 2.5 billion years ago, the buildup of oxygen began in our atmosphere by the phytoplankton, blue-green algae, you may know it as. And so as we move forward, there's this great oxidation event. It happened fast. The amount of oxygen was very, very quickly growing. Now, that was 2.5 billion years ago. What does that mean? It means that with photosynthesis in the oceans, we're certainly going to get this oxygen in the atmosphere. We're also going to get a situation where we are going to stand out like a sore thumb to any civilization looking for oxygen, aren't we? And that's exactly why I think they're here. Because they know that as I think they're carbon-based life forms. I am a carbon bigot. That's right. You're looking at a bigot up here on the stage. I'm a carbon bigot. I believe that life in the universe began from carbon, right? And this reminds me of a little side note. Side note on the side. Sorry for you guys over there. I'll be there. When I was getting my degree, I was talking to my astronomy director of our observatory there at the university, and I said to him these words, I think it's a populated universe. He's like, he was a heavy guy with suspenders. He was looking over his glasses like this. Mr. D'Antonio, why do you say that? I said, well, look, we're bilaterally symmetric. We're the same on the left and the right. Every life form on this planet has a form of symmetry, whether it's radial, like tulips, or five-sided pentamerism, like starfish, humans, bilateral, all right? So I go, based on that, okay, that's probably a result of the formation of how DNA splits and replicates. Not only that, I think also that as carbon-based life forms, we depend on oxygen as well. And so any oxygen in our atmosphere is something that can probably be noticed. And back then, in the late 80s, that's right, I'm not old, okay, he said to me, he goes, well, we have no evidence of that. And we didn't. We didn't. I graduated with my degree in 1983, and by 1988, we had confirmed our first planet around another star. I went back because what he said to me at the last time we met, he said, he goes, are you quite finished? And I said, yes, I am. He says, okay, get back in the observatory and leave Captain Kirk to us. So I went back in the observatory, I did my work, did my project, graduated, great. Well, 1988 rolls around, and we confirmed the first exoplanet. He didn't want to hear it, right? He was one of those older guys that just didn't have that flexibility that some of us have, you all have. So I walked to his office, and he's on the phone. Remember the phone you hung up to your head like that? Remember this guy? The phone that was here? The lovely U-shaped scoop? Okay? He was talking on the phone to somebody, and I lean around the corner, and I don't say a word. I just lean in and smile and wave, and he goes like this. It was only one planet. I've been fighting the arrogance of science ever since, okay? And most of you know that. So the truth is that when we look at our oxygen levels in our atmosphere, Stephen Hawking said we should keep our heads down, hide from the aliens, don't let them see us, okay? Too late. For 2.5 billion years, we've been sending the signal via our atmosphere out to the universe that there's life here. Why? Can oxygen be made other ways? Oh, yeah. We can make oxygen geologically. There's other ways to make oxygen. But the quantity of the oxygen in our atmosphere points to something that is more than just geologic. Why? Because if a geological event occurs and there's some oxygen made, it quickly gets absorbed. The ocean is a carbon sink, and it'll take in oxygen. The strata, oxygen loves to bind with iron compounds in the soils, and bam, the oxygen will be gone in short order. Short order being maybe 100,000, 200,000 years. However, our oxygen is being replenished. It's staying. So any civilization watching this planet can watch our oxygen levels and see that they're staying the same over the last decade or whatever, however long they want to test. So they see, it's like, Torg, I don't see any differences in this oxygen. I know, Fluke, I think we should go there and check it out. Okay, let's take the sport model. Okay, so this is why we became obvious to alien species, as I believe, because as far as I'm concerned, we're going to be a blazing blue beacon of oxygen that will be seen. And if they're carbon-based, they're going to say, there's life there because we're carbon-based, we need oxygen too, let's go. And they're probably scientists. That's how I view them. I think they're probably scientists because long ago, they evolved past the need to worry about borders and wars and jockeying for position and politics, all that crap. Okay, who agrees it's crap? Yeah, every hand should be going up. No, I'm kidding. No, but the point is, I believe in science. So the truth is, when we look at what we're trying to do as a primitive species, well, the James Webb is trying to look for oxygen indirectly, too. Remember I told you it couldn't see oxygen earlier, but it found that dimethyl sulfide signature. Well, forget that one. If it finds oxygen, how's it going to do it? If you look at oxygen in the spectrum that comes from a planet's atmosphere, oxygen is in the visible part of the spectrum. No, the James Webb doesn't look at that. If this is the visible part of the spectrum, the length of this table here, okay? Red, orange, yellow, green, blue, indigo, and violet, okay? At the red end and beyond is the infrared. There's heat down there, microwaves, radio waves, okay? And the infrared that the James Webb is looking in is down by the door. That's how far out of the spectrum it's going on that scale. I worked this out before, by the way, so you know. It's not vapor talk here. Okay, and I'm strange that way. So that's how far out it's looking. And it's doing that because of the nature of what it's hunting for. It's hunting for galaxies that are moving so fast and so far away from us that all of their light is shifted into the red. It's called redshift. And so if it's all the way into that far end of the spectrum, we can't hope to see it with a telescope like Hubble that looks here and a little bit into here. We need something that can look all the way down to the door. That's what James Webb does. So oxygen atoms, on the other hand, those are here. James Webb doesn't see that, but guess what it does see? Oxygen atoms also collide with each other. And when they do, you know what they do? They leave a signature out there that James Webb can see. And that means that James Webb can indirectly detect oxygen. And it would only be oxygen. So the James Webb can find oxygen. I think that's important. So now here's the next step, and this is probably why you're here. What technology can an alien race use and leverage to go interstellar? Obviously, we've got the point now where aliens have detected there's oxygen in our atmosphere of this strange little world. How are they going to get here? If they have chemical rockets like we do, there's probably no hope because the nearest star is Alpha Centauri, 4.3 light years away. Light takes 4.3 years to get here. We cannot go near the speed of light. If we go to the speed of light, we become pure energy. And that means that we would, of course, die. So at that point, we have to go less than the speed of light. And our chemical rockets, like the fastest rocket we had, New Horizons, went out there really, really fast. At the speed of that particular probe, it would still take 11,000 years to get to Alpha Centauri. I won't be back for dinner. Or the next dinner. So what is it then that they could use? They have to leverage something that takes them to do maybe an end run. Now, in 1994, Miguel Alcubierre came up with the Alcubierre drive, also known as the warp drive that you've heard of in the popular literature. It creates a bubble of space-time around the ship, a warp bubble, And effectively, you pull the universe past you as fast as you can go. That was actually pretty interesting because if you had the energy, you could get to Alpha Centauri in 5 days. That's right, 5 days. Join us for a trip. You may not die. You might die. All you have to do is hit a particle. We move them that fast. But see, it was a warp drive. You still went through the space, but you did it by warping space-time around you. And the concept of space-time is university-level course. We're not even going to go there, okay? Because that's not why you're here. But if you want to talk about other ways in which we could travel, the Alcubierre drive is mind-bogglingly slow. 5 days versus 11,000 years. That sounds pretty darn good. I could pack a lunch in a cooler. I could have enough for a week. Yeah, no, because unfortunately, 5 days is going to be too taxing. Too much energy is going to be required to get there. All right? So what do? Well, in order to figure out what we do, we have to deal with something called the fundamental forces. Who's heard of these? The strong force, the weak force, electromagnetic force, gravity. This is not a quantum mechanics class, I promise. But it's important because I want to talk to you about the weak force. The weak force is the reason you're here. Okay? The weak force governs beta decay. What's that? That's the ability for one atom to turn into another atom. So let's take an example. You have hydrogen. A hydrogen atom has one proton and one electron going in the cloud around it. Well, that one proton, you can add a neutron to the nucleus of that, and now you have something called deuterium. It's an isotope, a different way of looking at the same hydrogen atom. It's has different properties, okay? And if you use it to make water, then you have heavy water, You can even drink it. Tastes kind of sweet. Don't ask how I know. Okay. So if you have a hydrogen atom with a neutron in the middle, there is a possibility that neutron can spontaneously be caused to turn into another proton. All right? And now you have 2 protons in your nucleus. And what's that? Helium, another atom. Different one. In the periodic table, that thing we hated in biology, and we do it. Okay? But so that's what the weak force governs. And it works all across the periodic table. Okay? Next, we have the strong force. The strong force is the strongest force in the universe. Nothing is stronger. The only problem is it works over such a very small distance. It only works at the distance of about the diameter of a proton, which is, of course, very tiny. But it's extremely powerful. And so you add protons together. Protons are +1 charges. Okay? Like charges repel. It's like trying to put 2 north poles of a magnet together. You can't do it. It's like, they won't let you do it. But if you do this with protons and you shove them into a nucleus, the strong force is strong enough to bind these together anyway. All right? So that's cool. So the strong force. The electromagnetic force, electromagnetic. Electric, magnetic. Light is actually an electric and a magnetic field together. Okay? Think of it like this. They're perpendicular to each other. Electric field, magnetic field. Wow. I never knew it. Doesn't matter. But notice that I say wave and particle here, okay? Light can be seen as a wave, and we also talk about light in terms of photons, particles of light. Well, we have electrons, which are particles, but electrons can also be defined with a wave equation. So we have wave and particle nature with these other 3 forces. What about gravity? Where does gravity live on this scale? 3 out of 4 of these fundamental forces are covered by our standard model, okay? But gravity, we can't see gravitational particles yet. In fact, we didn't know we'd ever see gravitational waves. Einstein said we'd never see them. I can't do an Einstein impression because I don't know what he sounded like, to be honest. I think it was more like this, but I don't know, okay? Don't count on it. But gravitational waves were finally seen when we saw 2 neutron stars collide. Ripples in space-time. Absolutely astonishing. Now, these gravitational waves meant that, wow, maybe we're halfway there. Maybe if we see gravitational waves, maybe the gravitational particle's not far behind. And you'll never guess what. No, it hasn't been discovered yet, but over at CERN, they're looking for it. There's a detector there called the Atlas detector. It's, in part, going to look for special gravitons, which we're coming to shortly after this commercial break. No, I'm just kidding. Okay. So you have to say now, what technology then could an alien race use, knowing something about these fundamental forces? See, these fundamental forces are across the whole universe. We know about them everywhere. Everybody knows about them. They're all the same. Okay? So, and they operate the same way throughout the universe as far as we know. All right? Based on our observations of distant galaxies and close-by galaxies, everything seems to work the same way. So what technology could be used? Well, currently our standard model of physics won't cover it. Okay? What we might need, though, is a foray into string theory. Who's heard of that? Not the show. Several hands went down. Can you believe it? I wasn't asking about the show. That's fine. Okay, string theory is interesting. Okay, if we think about string theory, okay, think about this. If we have a particle, a proton, all right, it's not just sitting there. It's vibrating. Okay, it's going back and forth like this. All right, everything vibrates in the universe. Nothing is sitting still. This table is vibrating like mad. You have no idea because it's vibrating at such a small level. This podium is doing the same thing, okay? You are. Every atom in your body, okay, has this vibration going on. Now, if you look at this and slow it down, this is one end of the proton's vibration, and that's the other half. Take away the protons. You're left with this path in between them, the energy path. Think of that as the string. It's a different way of thinking about atomic structure, all right? However, what it affords us, if we can prove that this is correct, this affords us the ability to look at variations of the string approach to the universe and find ways to utilize that to wing our way to the stars in seconds, not thousands of years. So one of those particular variations of that theory is called Randall-Sundrum 1. You don't have to remember that, but just understand that it's very exciting because Randall-Sundrum 1 means that we think of the universe this way. We have X, Y, and Z moving through time. Those are 4 dimensions. Time's actually a real dimension that we use. Okay, 4 dimensions. Okay? And then we have a 5th dimension called the bulk out here. I'm waving to, okay, but this way, 4 dimensions and the bulk, all right? And then beyond that, we have something called the Planck membrane, all right? That's excluded from our discussion because we don't need it. So what happens now is that we look at this theory, and I know this is kind of getting thick, but bear with me here because it's going to come clear really soon, all right? This 4-dimensional location that we live in and this 5th-dimensional location are exclusive to each other. One cannot be within the other, but we can go from this one to this one using a particular construction, a particular particle set that can bring us into this 5th dimension. And as you'll see, this 5th dimension is very important because in that 5th dimension, the farther in we go, it's highly warped. The farther in we go, the smaller the universe becomes around us, all right? And that means that from within that 5th dimension, we can then punch out back to our 4 dimensions to a new location that might be, say, this far away, but this compressed. This could correspond to 10 light years, right? If we only go in a little bit, then this might correspond to 3 feet, okay? So depending on how far in we go, and I call it a punch-out, punch-in process. Depending on how far out we go, we might actually be able to travel many light years in one shot. And it's not something that is out there as a extreme possibility or even extreme theory. It's something that CERN is working on right now, as I'll tell you. Now, to give you an idea, in order to utilize this technology, you would need to create these special particles. These special particles are really important because you would have to generate them using something like a particle accelerator. So a particle accelerator might be well suited to fit inside a circular UFO or even a triangular UFO. So is it possible that UFOs are particle accelerators on their outside? I think this is highly likely, all right? And what happens is the outer ring of the accelerator that they have in there is dispensing these particular particles that allow them to move into this bulk, this fifth dimension, right? So we think of UFOs as maybe 30 feet in diameter. When we create particle accelerators, we make rings that are massive. CERN is 21 miles in diameter, or 20 miles around. That's huge. And the reason is because we're accelerating particles along this waveguide all the way around the accelerator, all right? And these particles are accelerating, but they're being constrained to turn in a curved path every split second. And that causes them to attain a different set of energies, which allows them or causes them to give off a certain type of radiation that's deadly to us, called synchrotron radiation. Aliens would have figured this out. So if they have a UFO that's circular, as we look from the top, the ring on the outside might dispense these particles we're talking about, and I'll get to that shortly. But on the inside, in the core, you can be perfectly shielded from synchrotron radiation, just like the folks at CERN are. Okay? So think about this. That's why, by the way, it's 300 feet underground when we look at the Large Hadron Collider, which is not this. Okay? So if you think about it, the circular shape lends itself to being put inside of a UFO, but still we don't have the power source yet to make these particles within the UFO. And that's what we're going to also talk about that. So if you're an alien race, you're going to have figured out how to handle that synchrotron radiation that comes from trying to accelerate particles in a circle using a magnetic field. You're going to come up with a way around that. So I say that for a race that's maybe 1,000 years ahead of us, I think they'd be pretty good at that. They'd probably figure that out. Torg, he would have figured it out. You know, and Floop over there, he would probably go along with them, you know. So that's how that would work in my idea. So what happens, though? What do these accelerators do on board a UFO, in my view? And it's not just my view, by the way. If you've ever heard of the book, Solving the UFO Enigma, it's written by Robert Schroeder, a good friend of mine. Bob is a phenomenal guy. You know him. Yeah, see? They know. Okay? I agree the book's a little hard to read because he throws Maxwell's equations at you and expects you to understand that. And he's a very good guy when you talk to him one-on-one. But the book, he had to get it out there. I love what he says in that book. And he talks about this whole concept. And the thing that's interesting is that if you have this accelerator inside your UFO, you can generate particles that allow you to go into that fifth dimension because that's where those particles are most comfortable, all right? And these particles are called Kaluza-Klein particles or Kaluza-Klein gravitons. These things are 10 to the 16th times stronger than the Earth gravitons that we still haven't found yet, but are theorized to exist, that are holding you to your seat right now, okay? And so 10 to the 16th is a very, very big number. So what does that do? Well, what that does is these KK gravitons also cause micro black holes. As soon as you release them, they're going to cause a micro black hole. We know that micro black holes can exist, and they would only live for a few nanoseconds because all black holes evaporate. Did you know that? All black holes evaporate. Now, the bigger they are, obviously, the much longer it's going to take. But micro black holes evaporate in just a few nanoseconds, they're gone. But if you keep producing them and put a constant flux of them around your ship, then you're going to get pulled right into that bulk, right into that fifth dimension, like hitchhiking, but in a much, much more dangerous but really cool way. Yeah, I don't know. I might refuse the first trip or two, see if they come back without 3 heads or something, you know. So that said, I think this is the secret to how they operate. And let me outline it for you. Okay, this is one of Bob's, actually, illustrations, right? It's mistaken in that the particles will be all around the ship, not just in the bottom. But if you think about it, these are micro black holes being emanated from the ship itself. They're very, very high gravity, 10 to the 16th times stronger. That gravitational field is what allows the ship to do what it does, and we'll see how. If you look at these micro black holes, what do? Well, first of all, they almost decay immediately, so they're not around for long, as I said, a few nanoseconds, okay? However, one of their big things they do is they observe the Earth gravitons that are holding you to the chair. They're not allowing gravity of the Earth to reach the ship. And maybe this is why UFOs are often described as fluttering in the wind like leaves. Because maybe they don't feel the gravitons of the Earth, so they're just fluttering like nothing's affecting them at all. And for the occupants, there's no up or down. They don't care. All right? So that's really interesting. All right? Now, this means that the ship is not subject to Earth gravity. All right? Now, the gravitons themselves, the KK gravitons, would actually pull that ship into that fifth dimension. And in that fifth dimension, okay, what happens there, time slows down for the occupants of the ship. And as I said, the universe is highly contracted around you. So what happens is then the travel time to anything in the universe is greatly shortened. There's the Stanford professor that said, calculated, a physics professor that calculated that if they used KK gravitons and a ship like this to go to Alpha Centauri, that would take a whole 20 minutes to get there with this process. Okay, that's better than 5 days. I'm in. All right? I'm in. 5 days, that's good. So that's pretty cool. And so this means then that when we see this, travel time is no longer an issue. For people that thought and people that think, well, the universe is so vast, how could they possibly be here? That's how they could possibly be here. And I'm not the only one. There's a lot of us out there that think this way. And this isn't, outrageous, pretend physics. This is actual, real analysis done on the concept of string theory, all right? You might have heard that Avi Loeb just came out recently, all right, and said that he thinks they travel interdimensionally. Well, what do you think of that? Okay? So, honestly, it's becoming more mainstream in that way. Now, you have to understand that when someone sees a ship operating like that in our atmosphere, okay, they're going to see it shimmering, changing colors. Why? Because those micro black holes are absorbing light as well and won't let light get away from the UFO. So sometimes it might look like it's coming and going, right? Well, the micro black holes will very efficiently do that. We might also see them fade in and out. Yeah, the micro black holes would certainly do that. And they might overtly vanish in one place and appear in another. Yeah, going back and forth into the bulk and then coming back, that would certainly do that. All right? Now, is this evidence of Kaluza-Klein gravitons? I don't know. I can't tell you that it is. But think about this. As an astronomer, I can tell you that things that flicker and change color, well, we have a name for that. It's called atmospheric scintillation. I get it. A star close to the horizon looks like that. Wow, look at Sirius dance. It turns blue, it turns red. Look at that. The spectrum is being broken up by the atmosphere, and the turbulence is making it dance. It's really, really pretty when you photograph it in video. Okay? And fading in and out, that could be something that's actually at the edge of your visibility, fading in and out. That's fine. Or it's changing an aspect ratio to you. I get it. That's true. Okay? Overtly vanishing in one place and appearing in another. I ran a night class on this out in the desert in Arizona, and I had 30 people. And they were looking at an object that was blinking in the sky, and it was there, and it was there, and it was there, and it was there. Meanwhile, I was taking a picture of the sky at the same time. And what did we see? They said, and I got their opinions. I said, what did we see? Well, I saw it there, and I saw it over there, and I saw it there, and I saw it there, and I saw it by that star. Okay, that's pretty specific. Then I showed them the photograph. You know what they saw? They saw a bright line. It was a time exposure. They saw a bright line, then a gap, and then a bright line, and a gap, and a bright line, all in line with each other. A tumbling satellite. When it turns like this to you, you don't see it. When it turns like that, you see the light. And as it's slowly tumbling through orbit, you see dash, nothing, dash, nothing. And I said, that's what you saw. But you all thought it was all over the sky. That's called the autokinetic effect, right? Your eye did not evolve the need to identify small objects in the sky precisely. If it did, you would know where they are and you'd know them, okay? But it didn't, so we don't use that. We don't need that. So, of course, we get fooled by it. So, yes, it could be the autokinetic effect, why these things fade in and out, all right? So, and change positions. So the point is, does this mean that Kaluza-Klein gravitons are not in play? Absolutely not. It means that phenomena that we see in the universe can be due to more than one thing. It's not A means B. It doesn't mean B means C and nothing else. A can mean B. A can also mean C under different conditions, and A can also mean D. Okay? Many of these things can relate to each other, and the same effect can be present for different phenomena, the same effect. One of those phenomena might be Kaluza-Klein gravitons in use. What do you think over here? Do you think so? Chad, what do you think? He says possible, yep. Does your wife agree? Yeah, she agrees. Yeah. Chad Wanless, he's going to be talking tomorrow. Make sure you listen to his talk. Okay? That's our man right there. He's a good guy. Okay, and then if you think about it then, what I would say about the verdict, okay, of this, in order for UFOs to do what they do, they have to generate massive gravitational fields. And I think that that's what they're doing. They're massive gravitational fields that operate over a very short distance and disappear very quickly. And then they keep metering the amount of those particles to keep a net number to allow them to constantly move back and forth from that fifth dimension back into our fourth. It's an oscillation. And they oscillate. That's how they work. How do I know that? Well, you're going to see, because there's more. I know. It's like, oh, it's not done yet. You know. But what happens is they oscillate back and forth. So guess what that means? It means that they're not really here and they're not really there. They're always kind of in between based on the type of oscillation they're doing back and forth. This means that when they're traveling through the air on this planet, they're not subject to sonic booms. They're not subject to the molecules of air because they're not traveling in a straight line. They're literally bouncing out and bouncing in a foot or so ahead of where they just were. Why? Because they don't have engines. They don't need them. They just have to dimensionally shift up into the fifth dimension and then target a point, and the targeting is the thing, the science that we need to learn. And then target just another foot or so ahead of where they were. And so they're doing this all across the sky. And that's how they're going from point A to point B. This looks like a straight line to us in our 4 dimensions, but in fact, they're doing it like this. Okay? And what do they feel? Do they feel, wow, look how we're going? No, they feel this. It feels like this to them because they're just shifting dimensions. They're not actually moving anywhere. When they reappear, they're in a different spot. Do you follow that concept? That's the thing that shows how come they don't feel tremendous G-forces when they go, okay? The reason is because they're just shifting. And so when they do that, they're going ding, 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 ding. It's just discrete numbers of points. But they're doing it very, very quickly. And to them, the end point doesn't take any time to get to. So they can just shift there any time they want and stay out as long as they want. They could shift away a light year and come back to the same spot they were just in as well. This sounds too good to be true, I know. But this is actually supported by future science that may be available to us soon. You know, so the question you might ask then is, well, where are they hiding then? Maybe they're on the moon, you know. We've heard this before. Are they on the far side of the moon? Ooh, you know. Are they in a perpetually dark crater? You know, are they inside the moon? I've heard so many people tell me the moon is hollow. Like, the moon's hollow. And they believe that. Why do you say that? Because it rang like a bell. Do you understand what ringing is? Okay, and literally, this is, again, I understand people get confused when they heard that. It rang like a bell, and they think of bells as hollow, right? Except that the reason bells ring is because there's a standing wave of air moving back and forth inside a hollow cavity that's open at one end. If it wasn't, you wouldn't hear that. It'd be thunk, okay, instead of bung, okay? That ringing of the material and the wall, the bell thickness, all is so important. So with the moon, that ringing like a bell was a really, really poor thing for whoever said that. I don't even want to know his name, okay? But he said it was wrong, okay? It didn't ring like a bell. Seismic waves traveled through the moon, went to the other side, and then the inside surface, they bounced back, and they were almost unimpeded. What would impede or slow down or stop sound waves from traveling through the moon? Differences in material. If you went through a molten core of a moon, it would tend to disrupt that a little bit, and you would be able to detect that. If it was mostly solid, then it would travel through relatively unimpeded, and it would ring like a bell. And that's why the moon rang like a bell, because it's nearly solid. It's not hollow. And for proof, you only have to go to Pennsylvania. Who knows why? Does anybody know about Ringing Rock State Park in Pennsylvania? Who's been there? Yes. See? A yes. You take your hammer and you hit the rocks, what happens? And that's it. Okay. When you hit the rocks at Ringing Rock State Park, they ring. Bing. Why? Because the composition is nearly the same throughout. So when you tap the rocks, you get this ring like an anvil. Anvils are solid. They're not hollow. Why do they ring? Same reason. So this is what happens. So we know then that there's nothing inside the moon. We know that the far side of the moon, they're not there. Why do we know that? Because the Lunar Reconnaissance Orbiter is so incredible, and you can see it too. All you have to do is go to this website, the Lunar Reconnaissance Orbiter Quick Map, LRO Quick Map. Look that up in Google. I always give away toys when I talk. This is one of them. And I apologize to your spouses. When you start looking at this, you're not going to want to come to dinner. You're not going to want to leave the computer. You're going to want to stare and dive into the Apollo landing sites and see the tracks left by the rovers. You're going to want to move around through craters, dive into the craters. You're going to want to go into 3D mode and go down inside the crater, looking out from inside. Oh, it's so really cool. And those of you with 3D printers, you'll want to use this too, because you'll be able to generate moon crater maps and print them on your 3D printer. Look, I made Tycho. You missed dinner. Okay, well, you know, Tycho. So obviously the moon is well covered by our satellites and by our technology, so that's not going to be it, you know? I hate to say. So where else could they be hiding? Well, they could be hiding in our oceans. And I know that I always say this, they go where we are not. All right? They go where we are not. And we've only really been able to catalog 16% of our Earth and the ocean floors. There's a lot left to do. When you look at Google Earth, it kind of gives you the false sense that we know all this stuff. And we have the ocean floor down pat. No, we don't. Those are interpretations to very, very coarse data. They're not exact interpretations and exact renderings. So this is something that's really important. All right. Now, reports of USOs, unknown submerged objects, have been around for many years. All right. Obviously, in 1957, the Kitsukawa Maru crew actually saw these silver objects entering and leaving the sea. And notice they give you the latitude and longitude of the observation. You know where that is? Marianas Trench. That's interesting. So, remember what I told you about the oscillation? They go where we are not. We're not in the Marianas Trench. Well, except for, what's his name there? Avatar guy, went down there, yeah, James Cameron, yeah. So, James Cameron, he came up to Doug Trumbull's studio one time. I wasn't there for this, but apparently he has this entourage, and they follow him, and so I get lockstep. Hello, I'm James Cameron. It's really cool. I didn't see it. Well, anyway, but he's supposedly a nice guy, one-on-one. This Marianas Trench location then might be a place where these things could be oscillating, because if you think about it, as I said before, they're neither here nor there. So if they're actually able to go somewhere, they're going to go as far away from us as possible when they just want to relax, not have to deal with us. That's the feeling. And where would they go? They'd go where we aren't, and that's down in the Marianas Trench. That's in the bottom of most oceans. Now, we have some subs that go deep, but I don't know if you're aware, but if the full ocean depth was the size of the depth of this room, our submarines only go down about 4 inches from the top of the ceiling. All the rest of this is a no-go zone. They can't go there. The research subs can go down there, but they're elevators. They go down and they go up. So they only visit briefly, right? Trieste did that. Alvin does that. Titan tried to do that, actually, yeah. And they didn't succeed. Well, they did for many times, but then the carbon fiber hull failed. I have all kinds of theories about that. I tried to say it wasn't going to work. So the bottom line is that it's possible that they're oscillating and in and out and just staying in that netherworld the whole time. And if your computer's doing it, and if your accelerator is making these particles for you, you can just sleep soundly because that's all happening automatically in the background. And you're just sitting there, listening to the hum of the accelerator. Hope it doesn't stop. Actually, you won't hear it stop. If it stops, you'll be gone before the sound reaches your brain. So the bottom line is that they could easily be hanging out here, all right? Because the fusion reactor will give them all the power they need, endless power. They don't need to worry about it, okay? So now, if we look ahead, now there's, in 1963, there was these maneuvers off Puerto Rico where these ships were on the surface and we had some submarines. There were 5 submarines underwater in this task force, and they were doing these maneuvers. And while they were doing these maneuvers, one of the submarines picked up this odd thing that was going on. It found an object that was seemingly going from the surface down to the ocean depth, deep ocean, in seconds. How could it do that? And it was also speeding ahead at 100 miles an hour and then slowing down. They would catch up and go far away. They confirmed it was not an instrument malfunction. It was a true anomalous reading on their sonar. All right? Could that have been a craft using Kaluza-Klein gravitons to stay at the edge of visibility? Maybe. I mean, I can't say for sure. That'd be arrogant of me to say that. I want to believe that, but I can't say it until we have the data, right? So clearly, these things have happened, and you know these guys. This was, we have Jeff, we have Kurt, and we have Don, okay? But I'll tell you a little story. Many of you know this, and some of you don't. As someone that was doing naval contracting for many years, decades actually, since the early 90s, what I ended up getting was an invitation to go out on a submarine. And I did. It was the most fun I had getting seasick. Oh, yeah. Yeah, just do this for about 2 hours with your eyes closed, and let's see what it does to you. Well, anyway, we get out into the Atlantic. I can't say where because I didn't know, okay? And I can't say why because I can't believe I did it. But the bottom line was I got seasick, of course, and I was supposed to have dinner with the captain in the wardroom. I did not want to get sick on him in the wardroom. That is highly embarrassing. And so once we got underwater, it feels like this, like you feel right now. Now there's little variations, little vibrations, you'd feel little vibrations as you went through water that changed temperature, okay? I told some of you this before. But once you cleared that, you were in a smooth sea, and you didn't feel, if there's a storm raging up there, you didn't feel it at the depth you were at, okay? Once in a while, you'd feel a little swell, but that was it. Enough to make you go, whoa, I'm underwater, So I sat next to the sonar guy that was reading the sonar. He had to be all of 21 years old, 22. And I was sitting next to him trying to get my stomach back, thinking, I got to see the captain. I am not going to throw up. Not going to, no, I'm not going to do that. Okay, so I started to try to listen to the noise. Submarines are loud inside, and they say that the quietest things in the sea. Yes, from the outside, but from the inside you hear shh, you hear all kinds of stuff, and all kinds of things happening. The sound doesn't get out typically. That's what it's about. So they're very loud. So the white noise was actually a help because I sat in the seat at this sonar station that wasn't active. This was active. There were 4 of them. 1, 2, 3, 4. 2, 3, and 4 were inactive. 1 was active. And the guy was using the sonar. And I sat there going, oh, man, get my stomach back. I'm drifting off, just like that guy. No, I'm drifting off to sleep. And just as I'm drifting off to sleep, I hear, con sonar, fast mover. I'm like, what? Fast mover, oh no. Was that a torpedo? I'm going to die. I should never have come on this trip. I was blown away. I was thinking I should never have come on this trip. Oh boy. And the executive officer No lie. This is what he does. He comes around by the sonar shack. He looks at the kid and he goes, "What do you got?" I'm thinking, a little more urgency here, pal, is what I'm thinking. And the kid turns to him and says, the bearing and the range to this object. And I didn't hear that because, again, the noise. However, the XO said, "What about the speed?" And the kid went like this in his seat. This is exactly what he did. "Several hundred knots, sir." And he said that so loud that I think the whole boat could have heard it. All right? And I'm sitting there like this going, Okay, calm down. USO, oh boy. Now, I'm thinking, I was invited on this cruise. I'm a big shot. Oh yeah, you know where this is going. So I got up after he delivered that. Well, first of all, the XO said to the kid, it was like this, because he didn't know what to do with it. A little side thing, sonar guys on a boat, sonarmen, are supposed to be able to identify every single thing they see. Yes, sir, that's a whale fart. 100% certainty. They need to know that. And believe it or not, they do have whale farts in their database. I'm not kidding. So that said, he didn't have a classification for something moving several hundred knots almost perfectly quietly in the ocean. Okay. What do I do, sir? You're on. You tell me what to do. And the XO just looked at him and said, "Log it and dog it." And the kid went, "Sir, yes, sir." And he went back to work like nothing happened. And now me, over here in my seat, Mr. Big Shot. Okay, I go, no. I get up and I walk over. "Excuse me, XO. I'm a big shot. I'm familiar with these fast movers. Is there something I can help you with, sir?" He goes, D'Antonio? "Yes, sir, sir, yes, sir." He says, "You having a good trip, sir?" I go, "Yes, I am." He says, "Let's keep it that way." And I was like, "I'll be back." Okay, so I literally shrunk away, okay, and went back to that chair. Seasickness? Gone. I wasn't seasick. I wanted to say, "Move over, kid. Let me see this thing." You know, I didn't know how to use it, but I'd have him teach me. But anyway, I was so excited. I couldn't wait to get back to shore, even though this was the most fun trip I'd ever been on. So I get back, and the XO looks at me, nods, and says, "Remember," you know, like, I can't forget. "Thank you for the trip, sir." You know? And about 4 years later, I did a job for the Joint Chiefs. It was actually a project for the Office of the President. So I go down there, and I meet with the chiefs, and I sit with them. And I see the chief that I worked with for one part of the project. And this is what happens, okay? You know, you get into something, you really are into it, and you know you shouldn't say something. And you know you should just keep your mouth shut. And in my head, I'm saying, don't ask him. Don't say anything. Meanwhile, the words are already coming out. "Sir, what can you tell me about the Fast Mover program?" And he looks at me and he goes, "Okay, I'm sorry, Mark, I can't talk about that program." "Okay, no problem." And I drove back from Washington, D.C. like this. I don't even know how I got home. I don't remember seeing the road. I drove on autopilot. All I was thinking of, it's true, it's true, it's true. Oh my gosh, it's true. I can't believe it's true. It's true. I can't believe it's true. Our U.S. Navy sees these things all the time. And since then, I've talked to other submariners who have seen them. On one boat, one guy said, "Yeah, we didn't know how to categorize them either, and we were told to just call them jellyfish." Jellyfish. Wow. You know, like mega hypersonic jellyfish. That's great. Wow. Can you see those guys? "I'm going fast." Look at me go. I'm leaving that submarine in the dust. Okay? But the truth is, okay, they're capturing them. They don't know what to do with them. They're not hurting us. We can't catch them. So we're told, observe and report. Isn't that crazy? That's where it lives. That's where it lives. And that's the extent of what we know. So when you ask where they're hiding, maybe they're right here. We don't know it. If you have any questions, let me know. My name is Marc D'Antonio. If you want to talk to me about our remote observatories, I've got business cards for everybody. Not everybody, but some people, the lucky few. And I'd be happy to take any questions if Forrest lets me. Here he comes. Thank you. How are we in time?
You can do whatever you want to do for the next 10 minutes.
Excellent. No, I'm not. Anybody have questions, I'd be happy to answer. If I have an answer. If I don't have an answer, I'll say, hi, hey, ask him. So let me know. If not, cool.
Thanks for that. That was great.
Thank
With these fast-moving underwater objects, wouldn't we be limited in understanding their true speed because sonar sound waves move that much slower than radar light waves? Is that a thing, or?
It's. I know what you're getting at. So the way the boats work is they have a trace. It's called a waterfall display in the older boats, and they actually show the object, a history of the object in motion, and that leaves a trail that they can then measure and calculate things from. So that's why they see it. And remember I talked about the discrete popping in? Every time they discretely pop in, they get a trace. And what that translates to our eyes or to a sonar is a line, okay, a path, because that's what we see, you know. But they're actually just doing that oscillation back and forth. I'm telling you, it's the only way it works. It's the only way it's going to work. Thank you.
So my understanding of quantum mechanics is that sometimes there's fluctuations that could cause like a non-causal horizon. Mm-hmm. So how would interdimensional travel reconcile for something like that?
I think that the answer lies in the understanding of the Randall-Sundrum 1 theory in string theory, because there you have a distinct set of, we call, we love to confuse people, and so do physicists. They will call it membranes. They'll say your X, Y, and Z movement through time is called a membrane. That's our home membrane. And the fifth membrane, that fifth dimension area is called the bulk. That's an actual real construct. So there we don't worry about some of that because we're actually just shifting to a fifth dimension, all right? Because those particles we're talking about, those Kaluza-Klein KK gravitons, to the rest of you, because you know what they are now, okay? The KK gravitons live there. So by generating them, we're there. See? So we skip all of the other weird quantum anomalies. Follow? Thank you.
I have kind of a weird question. I'm a molecular biologist.
You have a weird question?
Yeah.
What are you doing here? No, I'm just kidding. No one here has weird questions.
Do you think the KK gravitons could be affecting protein folding?
Ooh, I like that question. Well, not being a molecular biologist, I don't know how if I can answer that, but I can tell you that I wouldn't put it past us to find a way for that to happen, okay? Because as we're developing this technology, and I didn't tell you this, by the way, but I got to tell you now, okay? CERN is developing this detector called the Atlas that's already developed. You know what the purpose of it is? Is to look at and discern KK gravitons. That's the purpose. They're doing it for real, folks. And meanwhile, I'll get to your question in a second. Meanwhile, over here at Lawrence Livermore in San Francisco, they created a stable, extended nuclear fusion reaction. Sustained, okay? Not for very long, but they did it. No, they didn't get out more energy than they put in. Okay, we want that, but we didn't get that. But they got a sustained reaction. So that was a huge milestone getting toward the fusion reactor that we would need to generate these particles that CERN is now looking for. Isn't that cool? We're going there. Marry this to this, and we may have interstellar travel. Wow. This is why a guy at Edinburgh gave me his cowboy hat, because it put it, I'm not kidding, he put it all to, no, not your hat, I'm talking. I did the talk in Texas, and this guy, it put it together for me. He said, I have to give you my hat. And I guess that's something to a cowboy. I don't know that, but, okay. But going to your question, I don't know what it would do to our biology. From what I understand, shifting back and forth would be something that we wouldn't even notice. If this room was doing it, and it's all part of a big accelerator on the outside, keeping us safe in here from synchrotron radiation, if it was happening, the idea is that nobody in here would even know it's happening. If you had a window, you might suddenly see the ocean, then the bulk, and then the ocean, then the bulk, and just go and oscillate. But if we go up further into the sky or something, maybe we'd see the horizon and then the bulk, and then the horizon, then the bulk, and we'd see that for every single discrete path we go. But none of us would be affected physiologically in theory. I don't know how that holds true, you know.
I wonder if it could be actually used to design proteins.
Oh, well above my pay grade, I'm afraid. That's a great thought, though. Great thought. If I was Captain Kirk, I might say, we have to try it. Scotty. Anybody else? All right, if you want to meet up with me, I will be outside here wandering around like I'm lost. Okay, I'll have some business cards if you want to look at our Sky Tour live stream observatories. These are remote observatories. We bring you the universe live in real time. We take people on tours of the night sky. And we have Patreon, so you can get this final imagery. All the imagery we make, by the way, that we produce, you get for free. It's a free server at skytourlive.org. You can go there now and start taking down stuff today. All right, it's all free, skytourlive.org. And you can see vistas of the universe that are absolutely unparalleled because we've taken a regular telescope that is just a modest 10-inch aperture, and we've turned it into a superscope because we modified it to run 25 times faster than the scope that we got out of the box. And so when you're watching our show, you'll see things develop in 20 seconds that might take 2 hours to be done. And you'll see it happen in 20 seconds. And then we move on to the next one and next one. We've gone like 15 objects in a night. So people go to the directories of the latest objects and they say, wow, look at that, look at that, look at that. I want them all. And they can have them all. And it's free and there's no limitations. So we do this because we're passionate about astronomy, you know, and I think that that's something, to be honest, it's the rigorous application of astronomy that's going to take us off this planet. Okay, to be fair. It is the science of the future. Or Carl Sagan might say, it is the future of humanity, right? That's what I think. But thank you guys very much.